So this is for the first order differential equation. Now at the end of the last class, we introduced the second order equation. Okay, the second order equation. So the second order equation actually is we introduce this case, dy. The second order derivatives dy dx square plus p dy dx plus q equal to 0. Yeah, equal to 0. Here pq actually is the constant. Pq are constants. And for this equation, we say that we have the auxiliary equation. So the auxiliary equation is we replace the second order derivative by m squared. And we replace the first order, here is Q1, okay? Here is Q1. And we replace the first order derivative by M. So plus Pm, and plus we replace the Y by M by 1, okay, by 1. So here is the auxiliary equation actually is m squared plus pm plus q equal to 0. Yeah, equal to 0. So here for this equation, okay, we have three cases. The first case actually is this equation. We have two distinct real roots. Okay, so this distinct real roots. Okay, for this case actually is delta equal to p squared minus 4q is greater than 0 for this case. Okay, so for this case, the general solution is what? The general solution is yx equal to c1 e m1x plus c2 e m2x. Here m1, m2 are the distinct real roots of here. Okay, so here m1 equal to minus p plus the square root p square minus 4q. Okay, minus p plus the square root p square minus 4q by 2. This is m1, and m2 is what? M2 actually is minus p minus the square root p square minus 4q by 2. Okay, by 2. So here for this case, m1, m2. So the solution is yx equal to c1 e m1x plus c2 e m2x. This is the first case. Okay. Now for the second case is we have equal real roots. Okay, we have equal real roots. The second case is we have equal real roots. Equal real roots. For this case, actually is delta equal to 0. Yeah, delta equal to 0. So here actually is delta equal to p square minus 4q actually equal to 0. So in this case actually now we can see p square minus 4q equal to 0. So the m1 actually is minus p by 2. The m2 is also here is 0. So also it's minus p by 2, okay? So in this case, we have m1 equal to m2 equal to m. Equal to m equal to what? Equal to minus p by 2, okay? So in this case, we just have one solution. The solution is EMX. The first solution, okay? We just have this solution. So here y1x equal to EMX. This is the first, okay? The first solution. So now, because m1 equal to m2, so in this case, em1 and em2 actually they are the same, okay? So now we need to find another. We need to find another solution of this two order, this second order equations. So here we introduce another solution. Another solution is y2x equal to x times EMX. X times EMX. So here for this solution, okay, we prove that this solution satisfies this second order equation, okay? So here now let's see for y equal to x EMX. We show that, okay? We show this function, okay? This function is a solution of this second order equations. We show that, okay? Now we show that. So here, for this case, delta equal to p squared minus 4q equal to 0, okay? For the case delta equal to p squared minus 4q equal to 0. So actually it's easy to show, okay? So we need to find, for this y, we need to find the first order derivative, the second order derivative, and substituting the first order, the second order derivative to this equation. Yeah? So here now, for y equal to x EMX. For this function, what's the first order derivative? The first order derivative dy dx actually equal to what? Equal to x EMX derivative. Yeah? So here is a function times another function. So f times g prime equal to what? Equal to f prime times g plus f times g prime. Yeah? So here equal to f prime, x prime. X prime is 1. Yeah? 1 times EMX. So the first part is EMX. The second part is x times EMX prime. So EMX prime is what? EMX prime is MEMX. Yeah? So here x times m times EMX. So here should be mx times EMX. So this is the first order derivative. So the first order derivative, so here we can take out the EMX. So here should be equal to EMX times 1 plus mx. So this is the first order derivative. So now we need to find the second order derivative. So the second order derivative actually is equal to what? So equal to the derivative of the first order derivative. Yeah? So equal to the derivative of this function. Equal to the derivative of this function. So here actually should be equal to EMX times 1 plus mx, this function derivative, yeah?
Yes.
So here is a function times another function derivative. So equal to this derivative times here. So here equal to emx derivative times 1 plus mx. This is the first part. The second part is emx times 1 plus mx prime. 1 plus mx prime. So now here equal to what? The first part emx prime is what? Is n emx, yeah? So this prime equal to here times 1 plus mx. So this is the first part. The second part is plus. Here emx here is 1 plus mx prime is what? Is m, yeah? Is m. So plus emx. So from here now we can, it's easy to see, we can take out. Here is emx. So we can take out memx. So here actually is equal to memx. Here the first part is 1 plus mx and plus here plus 1, yeah?
Yes.
So the result should be memx times 2 plus mx. So here should be memx times 2 plus mx. Yeah? So here now. So it's easy to see for this function, okay? For this function, so here we can see the second order derivative plus p dy dx plus qy plus q1, okay? Plus qy. We need to see this equal to 0 or not. So the second order derivative equal to here. So we substitute it to, so memx times 2 plus mx, the second order derivative, plus p times the first order derivative. The first order derivative is what? Is it here? Is it here?
Yes.
So here is emx 1 plus mx. So this is the second part. The third part is plus qy. So here should be plus qy. Y is what? Y is x times emx. So here is q times x emx. So now we need to see this equal to 0 or not. If this equal to 0, if this equal to 0, then tell us that this function is a solution of the second order derivative, or the second order differential equation. Okay. So here it's easy to see. We can take out these three parts. We can take out the emx. We can take out the emx. So here, the first is n times 2 plus mx. So the first part is n times 2 plus mx. The first part. And the second part is p times 1 plus mx. P times 1 plus mx. The second part. And the third part is qx. Yeah? Qx. So we can calculate. Actually, is emx. Here is what? Here is 2m. Is 2m plus m square x.
Yes.
M square x. and plus p mx and plus qx. Yeah? Now we can see m actually equal to what? M actually equal to minus p by 2. Yeah? For the second case, okay, m actually is minus p by 2. Okay? M actually is minus p by 2. So here we replace m by minus p by 2. So here is what? So here actually is EMX. Here is we replace m by minus p by 2. So here is 2 times minus p by 2. And plus here m square actually is minus p by 2 square. So it's p square minus by 4. P square by 4 x, the second part, and plus p, and plus p times m. P times m actually is minus p square by 2. So minus p square by 2x, and plus qx. So here now we can see, because for this case actually delta equal to 0. Delta equal to 0, so here this means actually is what? This means p square equal to 4q, yeah? So here means q actually equal to what? P square by 4, yeah? Q equal to p square by 4. Q equal to p square by 4, so here q actually is p square by 4 times x, yeah? So now we can see here 2 times minus p by 2 actually is minus p. Here is minus p, here is p. So these two terms actually is cancelled. And here is p square by 4. Here is p square by 4x. Here is p square by 4x. Here is p square by 4x. So these two terms actually is p square by 2x. And here is minus p square by 2x. So the second term, the fourth term, and the fifth term, actually these three terms cancel. So the result is, so the first term and the third term cancel, the second, the fourth, the fifth cancel, so the result is 0. So the result is 0, so here tell us what? Here tell us that this function, okay, in this case, when delta equal to 0, in this case, x times EMX, this function is also a solution, of the second order derivative equation, okay? So here we have another solution, the first solution, the second solution. So the first solution, the second solution, and now we can see these two solutions, okay? This solution does not equal to a constant times this solution. Or this solution does not equal to a constant times this solution. So here tell us that this solution and this solution, they are linearly independent. So here means that we find, for this case, we find two linearly independent solutions. So the general solution actually is what? Is C1 EMX plus C2 X EMX. Okay. So here.
I didn't understand here the last one.
Why? Here. So here is 2 times minus p by 2. So here is minus p. So here minus p, here plus p. So these two terms cancel. Yeah? And here, this term is p squared by 4 times x. So here is minus p squared by 2x. Here is p squared by 4x. So this three term actually is p squared by 4x minus p squared by 2x plus p squared by 4x. So here, you take out x. You take out x. So actually it's p squared by 4 minus p squared by 2 plus p squared by 4. So this 0. So here means that this actually is 0. 0 times e mx. 0. So here, so for this case, okay, for the second case, equal real roots, okay. For this case, the general solution. So here, for the second case, the general solution, okay. So the general solution is yx equal to c1 times emx plus c2x emx. Okay, emx. Here m equal to what? Here m is minus by 2. Okay. So this is the second case. Okay. So for the second case, I give you example of this. So the second, okay, find the general solution of y prime minus 8y prime plus 16y equal to 0. Find the general solution, okay? Find the general solution. So first it's the same, okay? We need to find the auxiliary equation, okay? So the auxiliary equation actually is we replace the second order derivative by m squared and minus 8. We replace y prime, okay, the first order derivative by m, and we replace y by 1, okay. So here plus 16 equal to 0. So here m squared minus 8m plus 16 equal to 0. So we can see m squared minus 8m plus 16 actually we can rewrite it by what? Actually it's m minus 4 squared, yeah? M minus 4 squared equal to 0. M minus 4 squared equal to 0. So this tells us that m actually equal to what? 4. M actually equal to 4. So here this actually is we have equal real roots. Yeah, equal real roots. So from here we know that we use this result. So here actually is y1 equal to e mx. M equal to 4. So e 4x power. The first solution. The second solution is y2x. Here is y1x 4x half, y2x equal to x times e mx. So x times e 4x half, 4x half. So from here, y1, y2 we have. So the genuine solution, so here the genuine solution is the genuine solution actually is yx equal to c1 times y1x. So c1 times e 4x half, the first, plus c2x times e 4x half. So the genuine solution is like this. Here c1, c2 is constant, okay, is constant. So this is the second case, okay, the second case. So now we see the third case, okay. The third case here is for this equation, okay. The first case is distinct real roots. The second case is equal real roots. So the third case is what? The third case is for these two we have complex roots. Yeah, complex roots. So here means the complex roots. So the third case, okay. The third case is complex roots. Complex roots actually is delta equal to p square minus 4q greater than 0, less than 0, greater than 0, equal to 0, or less than 0. The distinct real roots is delta greater than 0. The equal real roots actually is delta equal to 0. Yeah? So here for this case is delta less than 0. Yeah? Less than 0. So for this case actually we have m1. We have m1 equal to minus p plus the square root p square minus 4q by 2, okay, by 2. The second is m2 equal to minus p minus the square root p square minus 4q by 2, okay. So now we can see here, because p square minus 4 actually is negative. So the square root of negative is what? The square root of negative. So for example, the square root of minus 1 equal to what?
Is 0.
Yeah.
No.
Complex number, yeah. So here now we can see this is a complex number. This is a complex number. So actually here, so m1 actually is we can replace, or we can validate a plus bi. Here actually is a minus bi. Okay. So this part actually is so here actually is a plus bi. A plus bi is complex, okay? Complex unit. So I square equal to minus 1. I square equal to minus 1. Okay? And M2 actually is, we can say, the real part, okay? The real part is minus p by 2. Here, this real part is also minus p by 2. Okay, so the M1, M2, they have the same real part. A actually is minus p by 2. M2 is also minus p by 2. So here they have the same real part A. And now we can see this is the complex part. Okay, complex part here you can see the complex part here is plus, here is minus. So actually they have the here is the plus bi, so here should be minus bi, okay? Minus bi. So this M1, M2 actually is a plus bi, M2 actually is A minus BI. So here for this case actually we have Y1 is actually is what? Is EM1x. Okay, EM1x. EM1x. So EM1x actually is what? Is now we replace here E, we replace M1 by A plus BI. Here is A plus BI x. So we can divide it by EAX plus BXI. Okay. Oh no, I should write it here. Here, this part we denote it by A plus BI. This part we denote it by A minus BI. Okay. A minus BI. So EAX plus BXI. So here actually is EAX times EBXI. So now do you study this formula? EIX how? Here I is the complex unit and X is a real number. So EIX equal to what? Equal to cosine X plus I sin X. We have this formula, okay? EIX equal to plus cosine X plus I sin X. So here we use this formula and replace this X by BX. So here we have this equal to what? This equal to EAX here is cosine BX plus I sin BX. So this is the first solution. This solution, okay, this solution actually is a complex number, okay. The first here this one and this one actually is the real function, okay, but this here is a complex function, okay. Complex real, because here we have I here. So this is Y1. So Y2 actually is the same, okay. Here is Y2x. Y2x is equal to EM2x. M2 is what? Is A minus BI, okay? A minus BI, so here actually is equal to A minus BIX. A minus BIX. So here we can divide it by EAX minus BXI. So we can divide it by EAX power times E minus BXI power. So here this equal to what? This equal to EAX cosine minus BX. Because we know here cosine minus BX actually equal to what? Equal to cosine BX. So here should be cosine BX and plus sin minus BXI. So sin minus BX, okay? Sin minus BX equal to what? Equal to minus sin BX. So here actually should be minus I sin BX. So here we can see this is the first solution, this is the second solution. And it's easy to see here, this solution does not equal to a constant times this solution. And this solution is also does not equal to a constant times the first solution. So here means these two solutions actually is linearly independent. So linearly independent, so here means the genuine solution actually is what? So the genuine solution actually is So here for this case, the GGB solution actually is yx equal to c1 y1x plus c2 y2x. So y1 is here, y2 is here. So here is c1 eax times cosine bx plus I sin bx. The first, okay? The first. The second is plus c2 eax. Here is cosine bx minus I sin bx. Sin bx. So here we can see eax times cosine bx. Here we have a coefficient c1. Eax times cosine bx. So we have a coefficient here c2. So here we have this equal to c1. So this actually equal to c1 plus c2 eax cosine bx. Eax cosine bx. And now we plus here eax sin bx. We now in the first term, the second part of the first term, okay, we have a coefficient of c1 times I, and in the second term of the second part of the second term, okay, we can see eax sin bx. We have the coefficient of c2 times minus I, okay. So here actually is c1i minus c2i, and here is eax sin bx. So here we denote c1 plus c2 by a new constant c3. So here is c3 eax cosine bx, and we denote c1i minus c2i by another constant c4. So c4 eax sin bx. So now from here we can see any geometric solution. Okay, the geometric solution can be expressed by a constant times this function plus a constant times this function. Okay, so here eax cosine bx and eax sin bx are two linearly independent solution of the second order definition equations. Okay, so this is the first solution. This is the second solution. Okay, so for this case, you need to remember y1x is equal to eax sin bx, eax cosine bx. The second is y2x. The second is eax and sin bx. So here a b is what? Here a b actually a is the real part. A is the real part of the root. The real part of the root. Okay. And b is what? B is the real part. B is the complex part. Okay. The complex part of the real root, the root. Okay. So here, this is the first solution, the second solution. So the general solution yx equal to c1 eax cosine bx plus c2 eax sin bx. Okay, so this is the result. Okay, this is the result. So here, so now we have introduced these three cases. Okay, and these three cases is the key point. So now we see the page 3, 432. 432 at the bottom. Okay, at the bottom we can see we have a summary. The equation y prime plus py prime plus qy equal to 0. So for this equation, we have the auxiliary equation m squared plus pm plus q equal to 0. So and now we have two forms. Okay, the first form is the case. The first case is distinct real roots m1, m2 of the auxiliary equation. So for this case, the general solution is y equal to c1 em1x plus c2 em2x. This is the first case. The second case is the equal real roots m1 equal to m2 equal to m. For this case, the general solution is y equal to c1 emx plus c2 x emx. This is the second case, okay?
Yeah.
And the third case is the complex roots m1 equal to a plus bi, m2 equal to a minus bi. For this case, the general solution is y equal to c1 e to the power x times cosine bx plus c2 eax power times sin bx. So this table is very important, okay?
So last why they write so smallly? They should write big letter.
So there's no way. The only way, okay? The only way you want to pass the examination is you should to save this table to your ear, okay?
Okay, now see, I write a paper and put gum then.
So you must remember it. Okay, you must remember it. So I think that it's not hard, yeah. It's not difficult, I think. But I think that maybe it is difficult for you because I find that on the answer sheet, okay, some students you come channel actually is more than 1 year, yeah. But some students cannot remember your ID. So I think it's so confusing. So I find that when I learn your marks, yeah, and I find that the ID and the name they are not the same. Since they are not corresponding. Okay. So I feel so confusing. You have 1 year. But you have 1 year, you cannot remember the number?
Yeah, crazy.
So I think the number is GJ2019. The first four is the same, yeah? 2019, so means the year, yeah? The second is 3500. So if you measure the same, the second four actually is also the same, yeah?
Yes.
And you just differently, it's the last four, yeah?
Last three.
Last four. So here means that you have 1 year, but you cannot remember 4 numbers. Yeah. So I feel so confused. So I hope that I hope that you can remember the table, okay? Remember the table. Of course, I will test the table on the final exam, okay? On the final exam.
Formula.
I will test it, okay? Of course.
Formula.
What? So now we introduce the 3 cases, okay? So now we give an example for the third case, okay? We give an example for the third case. So here, find the general solution of y prime plus y prime plus y equal to 0, equal to 0. So here, the first step is you must write the auxiliary equation, yeah? So here, the auxiliary equation is you replace the second order derivative by m squared, replace the first order derivative by m, and replace the y by 1. Okay, so here is m squared plus n plus 1 equal to 0. Yeah? Equal to 0, so here we can compute the delta. Delta actually equal to b squared minus 4ac. So here b is 1. So 1 squared minus 4, a is also 1. C is 1. So here is 1 squared minus 4 times 1 times 1. So the result is minus 3. Yeah? So minus 3. So here we can obtain what? We can obtain m1 actually equal to 2a minus b plus the square root of delta. Square root of delta actually is minus 3. Yeah? The square root of minus 3. So the square root of minus 3 actually is what? Actually is equal to the square root 3 times the square root of minus 1. Yeah?
Yes.
Square root of minus 1 is what? Is I. Yeah? So this part is the square root 3i. Yeah? Square root 3i. So here is 2. Here is minus 1 plus the square root 3i. So the first m1. Okay? m1. So m1 here actually we can divide it by minus half plus square root 3 by 2i. Okay, so the first. So m2 equal to what? m2 also equal to 2a. Here is minus b minus the square root of delta. So the square root minus 3. So here is what? So here it is minus 1 minus the square root 3i by 2. So this should be what? Should be minus half. And minus the square root 3 by 2i. Yeah? So from here, tell me what's A, what's B? A equal to what?
Minus
A, the real part. Yeah? The real part. So minus half. So B is what?
3 over 2i.
A is what? B is what? So you can see B,
3
A
over
plus BI, A minus BI. Yeah? So B should be what?
3 over 2. 5
Square root 3 by 2. Yeah?
Yes.
So here we have A, we have B. We have A, we have B. So here Y1 is what? So Y1 is EAX cosine BX. Yeah? We substitute the A, B to here. So here is what? Here is E minus half X. Minus half X. Cosine square root 3 by 2x. So this is the first function, or first solution. The second solution is y2x is what? It's also EAX power. Here is cosine, so the second is what? Sine, yeah? So here is sine bx. So here is EAX is also E minus half x. So sine bx is sine square root 3 by 2x. So the first solution, the second solution, there are two linear independent solutions. So the general solution actually is yx equal to c1 e minus half x cosine the square root 3 by 2x. The first, the second is plus c2 e minus half x. Here is sine square root 3 by 2x. Yeah? So this is the general solution, okay? The general solution. Oh, sorry. So we have 10 minutes. 10 minutes. Have a rest. So find the answer sheet here.